In this video, I'm going to give a brief demonstration of the core functions of the Keppel Biometrics framework for ODK Ecosystem devices. Here I'm using ODK Collect. In theory, this should work with KoBo Collect as well, and any other tools in the ODK ecosystem that use similar XLS form-based data collection. We recommend that you use the up-to-date entities-based forms if you want to recruit participants to a project and then later at a different time point validate their participation by scanning their fingerprint templates again. Basic setup here is I have a handset with a USB cable leading to the BioMini S3 device. There's multiple manufacturers that produce this piece of hardware. You can also buy tablets that have one of these integrated. This cost about $100 to buy. And we got it direct from Xperix in this case. So I'm going to open up a new form. We have a core functions form here, which you can download from our GitHub. Essentially, we have a launcher for a third-party app. We've written a third-party app called Keppel, which you'll need to sideload onto your device. That's also available as an APK file on the GitHub. So when we press launch, it sends a signal over to the device, and in this mode we press capture. That lights up the lights. I'm going to register my right index finger by pressing hard on the screen. Most important thing to look at first is the NFIQ score. So what's happened here is that we scanned a template. The onboard firmware here has converted that into a digital format and sent it back to the device. The NFIQ is a quality score, so 1 is the best quality you can get and 5 is the lowest quality that you can get. So we're going to always be looking for better scores like a 1 or a 2. If you were to get a 3, a 4 or a 5, you might want to rescan until you get a higher quality. In your ODK form in the background, the template is stored as a piece of code that you can look at and use in downstream assays. We also have a command line interface that will allow you to do more sophisticated matching algorithms. Here on the screen it's masked from the user. There's no reason to show this on the screen at this point, so by default we encourage you to use the masking. We have a fast mode. I think this is the mode you'll most usually use. So if you remember before, when I pressed launch, I had to then press capture. Here there's no such button. The light automatically comes on. I press my finger to the screen, and in fast mode it dumps exactly the same thing back. Here's another pretty high quality template, and that's masked again. But actually I've already registered my index finger, so let's change that one and rescan for my middle finger. So we've now stored 2 different fingers from my right hand. This is a better quality fingerprint. The quality often relates to the skin itself. My fingerprints are pretty poor. I've also got very dry skin, so I tend to get some quite low scores here. You can improve that by creating a better contact, either by flattening out as much as you can on the surface of the glass plate. Also, maybe a little bit of extra moisture sometimes. Use a sponge with a little bit of water. That creates a better contact. To validate, so in the background of this form, we've stored those 2 templates for my index and middle finger of my right hand. We're now going to launch the screen. We're not in fast mode here, so I'm going to click match. Now I can pick my index finger and put it on here. And we've got a reasonably high quality score, and we've got this validation score. So here, 258. We benchmark maybe 100. So if you have a score above 100, you're pretty much guaranteed that that fingerprint is the same one that you scanned previously. If it's lower than 100, let's try, for instance, scanning my pinky finger. So here you can see that we didn't get a very good quality scan, and there's no evidence that that comes from a finger that's on the database. Fast mode is the same as before, so we launch. Let's take my pinky, see if we can get a better scan this time. It's still giving a 3. If you were to look at my pinky finger, you'd understand why. There's no evidence that this is a match. Now, in the real world, I'd probably want to keep on trying until I get a better scan with regards to the NFIQ. Now, perhaps the most useful function on this software is the multi-match. So when we register a participant to a project, we might scan all 5 of their fingers, or possibly even 10 if we're really worried that we might have issues finding them again. We've already registered 2 of my fingers, so here we're going to try and validate either of my fingers against what's been saved before. So it doesn't matter which of my fingers I choose here, it's going to scan against both of the templates that are stored. And here you can see that it comes up with a high quality match, albeit a particularly low quality scan. We could try again with a different finger where I might get a better scan. And you can see with my middle finger, which gave me a higher quality when I registered, it's also higher quality this time. So I've got a really good quality fingerprint match here, both in terms of the quality score itself and in terms of the validation score. So in theory, you could store 5 fingerprints quite easily, and you could then match one validation print against all of those 5. As you've seen here, when you don't get a great quality from an NFIQ score from one of these fingers, you can try a different finger on that multi-match. And that's the core functions of this software. When we send it up to ODK Central, these templates will be stored as code. All of the validation templates will be stored. All of the registration templates will be stored. Fast mode is also available for all of these functions, so that you don't always have to press a match button on the screen, which saves you both time in terms of button presses and in clock time.